Alright, when simplifying trigonometric expressions, what you want to do is get them to one to be a single term if possible. So right here for this one, we have tangent x times cosecant x. So the first thing I'm going to do, my first strategy is going to be to convert it to sines and cosines. So this is going to be sine x over cosine x times 1 over sine x. And by doing that, you see that sine x over sine x is 1, so that eliminates the sine x. And so now we have 1 over cosine x, which is secant x. Oh, and that's letter A, by the way. Now for 24, you have to train yourself to recognize Pythagorean identities. So 1 minus cosine squared theta is sine squared theta. And there's nothing I can do to help you with that other than just you've got to know the identities. You have to recognize them, look for them, and substitute them whenever possible. So here you have cosecant is 1 over sine. And so sine squared x over sine x, I can cancel out 1 sine x here and 1 from here, so that it just leaves you with sine x. And that is letter F. Alright, so 26 deals with cofunctions. So the cofunction of sine is cosine, so this becomes cosine x. The cofunction of cosine is sine, so this becomes sine x. So cosine x over sine x is cotangent x. That one's letter C. Alright, so number 28, I'm just going to bring down the cosine squared x for now. And then in the parentheses, that's actually tangent squared x. It's one of the Pythagorean identities. It's rearranged. And so that's what it equals. And so tangent, I'll copy this one down again. And this is sine squared theta x over cosine squared x. And so the cosine over cosine squared cancels out. And so you're left with sine squared x. And that's a new group of problems, and that one's letter C. Alright, so for cotangent x, I'm going to convert that, or substitute it for cosine over sine. Secant is 1 over cosine. So I see that cosine over cosine is 1. So I'm left with 1 over sine x, which equals cosecant x. And that is letter A. Alright, so we have a cofunction in the numerator. The cofunction is sine squared x. And then the denominator stays the same. Okay, so now I have, I can break up the sine squared x like this. And this becomes tangent. And so that would be letter D. So the reason I took these steps is because I wanted to match this problem with one of the answers in that set of problems. Okay, so that's why I took the step. I could have stopped here, but that was not one of the options. So I kept going until I got this over here. Okay, so we're no longer matching. So I'm just going to simplify as much as I can for each one. So cotangent is cosine over sine times sine x. So sine x over sine x is 1. So I'm left with cosine x. Okay, so I've got cosine x. Now in the parentheses I have a Pythagorean identity. It equals secant squared x. And secant squared x is 1 over cosine squared x. So I can reduce this by 1 cosine and 1 cosine. So that leaves me with 1 over cosine x, which is secant x. Alright, for 39, there is for all of these actually, for most of these, there's several ways of approaching them. What I'll do for this one is convert this one to, 1 over cosine. Oops, it's not x, it's alpha. And so notice how I have sine over cosine alpha right here. So I'm going to convert this to tangent alpha, sine over cosine, and then the one in the denominator, 1 over tangent alpha, reduces to 1. Okay, so here we have, I can use a cofunction identity. So for cotangent pi over 2 minus x, it's tangent x. And then I have cosine already there, so tangent is sine over cosine. And so the cosine over cosine reduces to 1, so the answer is sine x. Okay, so I'm going to convert the cotangent to cosine over sine, so cosine squared x over sine squared x. And I know that in the parentheses is a Pythagorean identity, a rearrangement of it, right? So 1 minus cosine squared x is sine squared x. So sine squared x over sine squared x is 1, and you're left with cosine squared x. Alright, for 48, I notice that the numerator is difference of squares, so I'm going to go ahead and factor it. Cosecant x plus 1 times cosecant x minus 1, all over cosecant x minus 1. Okay, so again, this factor and this factor are the same, so I can cancel them. And so you're just left with cosecant x plus 1. So 51 is a difference of two squares, so you get sine squared x plus cosine squared x times a quantity of sine squared x minus cosine squared x. So the first factor is a Pythagorean identity, and it equals 1. So then your answer would be sine squared x minus cosine squared x. And I know this is difference of squares also, and you could factor it again, but it won't simplify any further, or you won't be able to replace it with anything to simplify it more. So this is actually considered the most simplified way right now. And that's the end of the homework.